So hello student, here is a question in which it is required to find the value of k such that the given equation has a specific condition that it has real and equal roots given, and we also need to find the roots of the equations. So in this type of question, first of all we have to focus over here that the given equation is in the form of quadratic, ax square plus bx plus c, in which a, b, c are real numbers and a is not equal to 0. Since the question has a condition that the quadratic equation given over here has real and equal roots, and we know that the condition for a quadratic equation to have equal and real root is possible only when the discriminant, that is d, is equal to 0. So on comparing these two equations, we have the value of a, the value of b, and the value of c. So what is discriminant? That is d, and the formula for finding the value of discriminant is b square minus 4ac, where b is the coefficient of x, a is the coefficient of x square, and c is constant, that is all real numbers. So we have b square minus 4ac is equal to 0. On putting the value of the given coefficients from above comparisons, we have 2 times of k plus 1 raised to the power whole 2 minus 4 times of 3k plus 1 times of 1 is equal to 0. On applying the formula for the a plus b raised to the power 2, we have 4 times of k square plus 2k plus 1, and simply this should be multiply. So minus 4 times of 3k is equal to minus 12k, and minus plus minus, that is 4 ones are 4. So on multiplying the 4 with the bracket items, the result will be 4k square plus 8k plus 4 minus 12k minus 4. This 4 and this 4 is cancelled out, so the required result is 4k square minus 8k minus 12k is minus 4k. So 4k square minus 4k is equal to 0. Then we have to take the maximum common from the given terms, that is 4k. As we have taken 4k common from the equation, the remaining portion is k minus 1 is equal to 0. Now 4k times of k minus 1 is equal to 0, then it is possible only when either 4k is equal to 0 or k minus 1 equal to 0. If 4k is equal to 0, then k is equal to 0, and if k minus 1 equal to 0, then k is equal to 1. So the value of k is either k equal to 0 or k equal to 1. This is the first part of the question. Now we have to find the roots of the question also. So if we considered the first value of k, that is 0, then the equation will be, on putting the value of k over the given equation, we have x square plus 2x plus 1 is equal to 0, which is clearly visible that this is a plus b ka whole square. So x plus 1 times of x plus 1, this equation can be written as x plus 1 times of x plus 1 is equal to 0. So the value of x equal to minus 1 or minus 1, that is the required roots, alpha is equal to -1 or beta is equal to -1, and this is the solution for which the equation has real and equal roots. Again we have to consider the other value of k, that is 1. The equation will be 4x square plus 4x plus 1 is equal to 0, which is also exhibited in the form of 2x plus 1 raised to the power 2, that is a plus b ka whole square. So on factorizing it, we have x is equal to either -1 by 2 or x is equal to -1 by 2. So alpha is equal to, the first roots of the equation is -1 by 2 and the other root is -1 by 2. So in both the scenario we have two values of k's, that is k equal to 0 and k equal to 1. Corresponding to the value of k, there are the roots which is equal and real, that is alpha equal to -1 and beta is equal to -1, and corresponding to the value of k equal to 1, alpha equal to -1 by 2 and beta equal to -1 by 2. This is the solution, complete solution of the given question. Hope you have got the concept of this question, as it is very helpful for your examination. Thanks a lot.